Alright, your question on this is how did they get the 1.645 for a z of 0.05? And so there's two different ways to do that. You can do inverse normal in the calculator, and you can type in 0.05, 0, 1. That will give you a negative 1.645, which is fine. The critical value is just always assumed to be positive. You can also, the long way is to look it up in the chart. I believe it's table 5, the standard normal table. This is kind of a pain. You have to go find 0.05 or as close as you can get to 0.05 and then work out backwards to find the z-score. I talk about that in my video, but that's not the most efficient way to do it. I would use your TI-83 or 84 calculator, go to second, and then vars, and I believe it's the third option. You'll see inverse normal. You put the area to the left, 0, and then 1. And so that's the 0.05, because the alpha is 0.01, but it's with 90% confidence, the 10% left over gets split between the two tails. Sorry, I was thinking chapter 10. So that 90% confidence has 10% left over in the tails, and it gets split evenly. That's why they call it alpha over 2, the leftover divided by 2. So that's where that 1.645 comes in. Then you can plug it in to the formula manually. On this question, because they gave you X, N, and the confidence level, you can also go to stat, and then you can go to tests, and you can choose, this would be a 1 prop Z interval. And you can, again, you can watch my video. I have the calculator, don't have my calculator with me tonight. But you can look in the calculator and find that. You can watch my video to see how I do that in the calculator. You basically type in X, type in N, type in what's called the C level. That's a decimal. So X would be exactly what you see, 121. N would be 220, and confidence level would be 0.90. And I believe it says calculate underneath that, and it automatically gives you the interval. So you can do it this way. It takes a little bit longer. There's a little bit more room for error this way, but the calculator can do this as well for you. But that's how to get your critical value, either in the calculator or by hand. And this is how to get the entire interval all together in the calculator. So I hope that was helpful. Let's see, I think I have them all loaded here. Your other question was how to get that critical value. So 82% confident is in the middle of the curve. So if you draw yourself, you don't have to do this every time, but sometimes it helps the first few times you see it. 82% confidence is in the middle of the curve. So that 82% is here. So you always want to do 100%, which is the whole curve, minus the 82 in the middle. That leaves us 18%. And you always, they call that alpha. And you always divide that by 2. The reason we do that is we split it evenly between the two tails. So what that gives us is 9%. So that leaves 0.09 in the top tail, 0.09 in the bottom tail, or 9% here, 9% there. All together, that's 100%. So anytime it gives you a level of confidence, that defaults to the middle of the curve. And so you take what's called the leftover. I call that the leftover, whatever's left from 100% or 1, whichever way you want to think about that. And that leftover, we call it alpha, and we always divide it by 2. We split it evenly between the tails. So that's why they call it z of alpha over 2. And again, you can look up 0.09 in the chart, table 5. It's kind of a pain. You have to go through all those numbers, find as close as you can get to 0.09, and then work your way out to get that z-square. That's the only way to do it. The quicker way is using inverse normal in the calculator. 0.09. If it ever asks for a z-score, you put 0, 1. Z-scores are always have a mean of 0 and a standard deviation of 1. So that will give you the z-score for that particular area. And if it's negative or positive, it doesn't matter. We just always, for critical value, we always assume the positive. So you always put a positive answer here. If it wants a z-score, then it depends. But if it wants a critical value, we always assume the positive of whatever that number is. So hopefully that was helpful. I think I've got the Chapter 8 question here. Again, in your email, I think you're trying to do this the long way, which is totally fine. It just is a little bit more frustrating sometimes. And so you were right. I believe you said the z-score was negative 1.28. I think that's correct. You can double check that again by doing inverse normal of 0.10, 0, 1. That should give you that negative 1.28. Let me check your email real fast, make sure that's what you said. Sorry, let me just double check. Yeah, negative 1.28. Okay. So with that z-score, you can set up the z-score formula, x minus mu over sigma, which looks like you did that correctly. We're trying to solve for x. We know the mean. You put it in the email. There it is, 21.7, and that's divided by the adjusted standard deviation, which I think you had that decimal. Let me check again. 0.6708. Okay, so you can do it this way, and the way you would have to solve that is first multiply both sides by that denominator. Multiply this by that denominator. What that would do is eliminate that denominator. I'm going to bring it down here so you can see better. So 0.6708 times negative 1.28. That should give you a negative product equals x minus 21.7. And then all you'd have to do from there is add 21.7. And so that should give you that. I don't think the answer is 3.6. That seems way too tiny. But whatever your denominator was, 0.6708 multiplied by your z-score, negative 1.28, equals x minus 21.7, and then add the 21.7. Now, once again, the calculator can help you out here. And if you watch the video that I made, hopefully it's pretty clear. If it gives you, if you already have, let me move the window here real quick. Okay. If you already have a mean given, 21.7, and a standard deviation given, 4.5, in the calculator you can do inverse normal again, but this time we'll do 0.10 because that's our 10% chance of being at or below. And instead of doing 0 and 1 to get a z-score, you can do 21.7 and then 4.5 over the square root of 45, or you can type in that 4-digit decimal either way, same thing. And that should give you the x value that you need. So with 0 and 1, it gives you a z-score that could be used for any type of problem. If you have a specific mean and a specific standard deviation, it will give you the exact x value you need to answer the question. So I hope these videos were helpful. If not, just let me know and I can record a different video tomorrow if you need.